This is Unit 12, Electrochemistry, Lesson 4, Half Reactions. How are half reactions for redox reactions written? The objectives of this lesson, I can write half reactions for oxidation and reduction, and I can balance redox reactions. Do now. So half reactions show either the oxidation or reduction portion of a redox reaction, including the electrons gained or lost. The moles of the electrons gained is equals the moles of electrons lost. So every redox reaction consists of one oxidation half reaction and two reduction half reaction. So for example, here is my full formula. 2 magnesium plus oxygen is going to produce 2 magnesium oxide. I first have to assign oxidation numbers to every element. And then I'll determine which one is being oxidized and which one is being reduced. As a result of that, I can write my oxidation half reaction, where I'll take out the magnesium, which will produce the magnesium ion, and it's lost 2 electrons. So that'll go on my product side. Oxidation number has increased. The reduction half reaction will be the oxygen that has gained 2 electrons, so I'll write those as reactants, and that will produce my oxide ion. The oxidation number has decreased. So here are the list of rules for setting up half reactions. The step-by-step process is you will first assign oxidation numbers to all the elements in the reaction and determine if it is a redox reaction. So you have to look for a change in oxidation number of 2 elements. One will go up and one will go down. Determine which species is oxidized. So the loss of electrons is oxidation, and which is reduced, which is the gain of electrons is reduced. So use the brackets so that you can keep those straight. Then break the overall reaction into oxidation and reduction reactions, called the half reactions, by pulling out the brackets. So I kind of imagine we're pulling those brackets apart, and we're going to pull out each of those 2 pieces. The spectator ions, those that do not change oxidation state, are left out of the half reactions. Next, fill in the electrons for each half reaction. The oxidation electrons lost will be on the right side, and for the reduction where the electrons are gained will be on the left side. Finally, check to see if the charges are equal on both sides of each half reaction. So, for example, we'll go through the steps. Step 1, assign all the oxidation numbers. So here, copper is 0, silver is +1, and nitrate is -1. On this side, copper is +2, nitrate is -1, and silver is 0. My nitrate is my spectator ion, so I can take that out. So I'll write NO3 is my spectator. He's just going to watch. Now, because copper is losing electrons, it's oxidation, so I'll write copper with its 0 charge will produce the copper +2 ion, plus those 2 electrons that are lost. The reduction is the silver, which is gaining electrons, so it's has a reduction in its oxidation state. So my silver ion +1 will be gaining 1 electron, which will make it become silver with no charge. So set up both half reactions. You're given this equation here in the middle. Calcium begins with a 0 oxidation state. Copper has a +2 oxidation state. That's what they gave you. On the other side, calcium has a +2 oxidation state, and copper is now 0. So because calcium lost electrons, it's being oxidized. And because copper gained electrons, it's being reduced. Therefore, I'll pull out my brackets. So my oxidation is the calcium with the calcium ion and the 2 electrons lost. And the reduction is the copper gaining 2 electrons and becoming reduced. So to balance the redox reactions, recall that in all redox reactions, there is a conservation of charge and mass. In all reactions, there's a conservation of charge, mass, and energy. But for redox purposes, we'll focus on these 2. But all reactions have a conservation of all 3 things. So the steps to balance, you first write out the 2 half reactions, including the electrons. So you first go through the first part we've done. Then you'll multiply the half reactions by the number of electrons in the other half reaction. Multiply through and put the resulting coefficients back into the original equation. So here I've got my oxidation half reaction and my reduction half reaction. Over here, there are 2 electrons, so I will multiply the other one by 1 electron, and then I'll multiply the first one by 1. Once I multiply them through, my 2 electrons will cancel out, and I can put those 2 coefficients back into the original formula. Oh, it should be this circle. All right, now the mass and charge are conserved. So for example, 2 examples. First, assign oxidation numbers. So calcium is 0, copper is +2, calcium is +2, and copper is 0. So because calcium is losing electrons, it's my Leo, it's my oxidation. And because copper is gaining electrons, it's my Ger, it's reducing. So the oxidation half reaction will be the calcium. It's going to produce my calcium +2 ion and the loss of 2 electrons. My reduction will be the copper +2 ion will gain 2 electrons, which will then produce my copper metal. So because my electrons are equivalent, I don't have to balance anything. They're all equal. So balance the following reaction. Potassium is 0, zinc is a +2, and chlorine is a -1. Potassium is a +1, and chlorine is a -1. So this is my spectator ion, and zinc is a 0. So potassium is losing electrons, therefore it's oxidation, and zinc is gaining electrons, therefore it's reduction. So my oxidation half reaction will be my potassium is beginning. It will lose 1 electron to become potassium ion. My reduction will be the zinc ion is gaining 2 electrons, and it will become the zinc metal. Now I will multiply through by the opposite, so I'll multiply this by 1 because there's 1 electron, and I'll multiply this through by 2 because there's 2 electrons. So then 2 potassium plus zinc chloride will produce 2 KCl plus zinc. And now we have a balanced charge and mass. So check your understanding. And now you can write half reactions for oxidation and reduction, and you can balance those redox reactions.